to hear. So my name is Cueni. I'm the systems engineer for Tenable in Switzerland. I'm doing Austria and Switzerland. Of course, I'm specialized in vulnerability management, vulnerabilities. But the topic of the talk today is a little bit different. It goes reducing the cyber exposure gap. So first question, what is the cyber exposure gap? That's probably not something you are aware of or a term you have already heard and are working with. And then it says reducing the cyber exposure gap from cloud to containers. So the question is, what are containers? Who is working with containers? Who is Docker? Wow. Okay, that's quite a high number. So let's first address the first point, which is the cyber exposure gap. So what is the cyber exposure gap? Now, if you look at the IT environments we have in companies today, we have a base layer, which are the classical assets as servers, desktops, network infrastructure, firewalls, and so on. But, and this is also where we are used to do vulnerability management. Who knows? I know I'm asking a lot of questions today. Who knows Nessus? Everyone knows Nessus, right? It's the world's best known vulnerability scanner. So classical, traditional vulnerability management is dealing with the bottom layer here with servers, desktops, and the classical IT assets. But the world today is different, right? We don't have only that base layer. We have web applications, we have virtual machines which proliferate into the cloud, mobile devices, people bringing their own devices to work, laptops that are in the company elsewhere, and that's not where it stops. I mean, we manage vulnerability management for web apps, for virtual machines pretty well these days. So we can say that's okay. However, there is even a step which goes above and beyond that. So many assets today are in the cloud, and that's where container and DevOps come into play. So how do you manage vulnerabilities in containers? Containers have an average life of like 2 days. Some of them only a couple of minutes or a couple of hours. You're not going to patch. You're not going to do patching on containers. So that's a whole new world you need to deal with when speaking about vulnerability management. And then just to complete the picture, even that is not the entire story. Today we have IoT, we have enterprise IoT, webcams, closing systems, but also industrial IoT, ICS, SCADA, and so on. The focus of today will be the container part, but this is really the whole picture we have to deal with in vulnerability management today. Vulnerability management today is no longer just your Windows desktop and your Linux servers. It's this whole thing here. And that's where the cyber exposure, or what we call the cyber exposure gap, comes in. The cyber exposure gap is basically the difference between what you have in your environment, or what you think you have, and what you actually have. And especially with regards to containers, that gap is very, very real, because the security people in your company might not be aware that DevOps are rolling out things in production every couple of hours. So they might think they have just the bottom layer, when in reality all the red parts are present as well. And this difference between what you think you have and what you can deal with your legacy tools And what you really have, which is the entire attack surface, is what we call the cyber exposure gap. In other words, it's the business risk that you have, because you cannot protect what you can't see. This is clear. So if we look at the definition, cyber exposure is really about actively managing the modern attack surface, and the modern attack surface is important to note because it really comprises all these things we have seen in the previous slides. So it's about managing and measuring the modern attack surface to understand and reduce risk. So the questions we deal with regard to cyber exposure are really, where are we exposed? And this is really, really essential because you only can protect what you can see, what you know about. So you need to know, where are we present in the cloud? What are we using containers for? Where are we using containers? Second point, prioritization. I have not seen one single company that says, okay, vulnerabilities, we just have a couple of them, so thank you very much, and it's okay. Every single company I have visited, they have way more vulnerabilities than they have people to deal with that. So prioritization is really important, and this, we will speak about this with regards to containers. And then vulnerability management is a continuous process. So the question is really, how do we deal with vulnerabilities over time? How do we involve? How do we get better? So this is the general topic of cyber exposure. Now we need to apply this to containers and DevOps. So what is DevOps? Is it just taking the development team and the operations team and bringing those together? And I like to think of it as mixing water and oil. It's not just bringing dev and ops together because you will get something like that. It doesn't mix. It doesn't mix well. DevOps is more like bringing down the barriers between these three areas: development, quality assurance, operations, to put the right tools in place, such as that the interaction between those three areas is really smooth and has no boundaries. And it's also about putting the right processes in place. So if you look at it from another way, whereas years ago, some of you might still remember that software design was really about the design phase, then a very, very long coding phase, which could be months before that thing that was created was tested and deployed. It then went to agile development, where there was still a design phase, a little bit of coding, immediate testing, a little bit of coding, immediate testing before it was deployed. DevOps is really a continuous movement of coding, testing, deploying. If you look at Amazon, they deploy changes into production every 11 minutes. So speaking about continuous development, that's really what it is, every 11 minutes. And if you have a process like you see here at the bottom, of course, there cannot, it must really be seamless, and the process and the tools must work such that these processes are really possible. And of course, that's where security comes in, because if I speak about seamless and processes, security and also vulnerability management must be part of this continuous process, which you see here at the bottom. Or in other words, if you have development where you create software, you verify, you package it to be released to the operations team in a seamless way, which then monitors the operation. Security must fit in here. So if we look at the verify part, of course, verify in this context, in the development context, means the software must work, you must get rid of bugs. But this is also, this verify part is also where security comes into play. So it should be very, very normal that during the build process of software, security is also part of that and is integrated in the developers' workflows. So DevOps. Next up are containers. So just to put everyone on the same level, containers are really self-contained packages where all the necessary things to run an application, such as dependencies, libraries, binaries, configurations files, are in that package. And if you look at it from an architectural point of view, and you compare it with traditional virtual machines where you have a physical server, you have a hypervisor, and then you have the different guest OSs which are present for every virtual machine with the necessary bins and libraries and the applications. It's much more efficient if you look into the container world. You still have a server on which you have the Docker engine running, and then on that Docker engine you have the different containers which share the kernel and the operating system that is present on the physical server. So this is not multiplied as with the virtual machines, which means it's much more efficient because containers are much smaller. It's also much more resource intensive, whereas it takes a certain time and certain resources to spin up a virtual machine. A container can literally be spun up in the fraction of a second, which means you can use them in a very, very dynamic way. And if you think about Netflix, for example, it makes really sense to use containers rather than VMs. Netflix, for example, they use a dedicated container for every video that is watched. So, of course, it's not possible for every video that is watched to spin up a traditional virtual machine. It takes too much time. It is too heavy on resources. So containers are made for exactly that. And if we speak about container, we must also speak about Docker, which is the most popular platform for containers today. Makes it really easy to integrate. It works well together with the DevOps philosophy we have spoken about before. So because containers are small and efficient, they can easily be deployed, they can easily be changed. If you make a small change, you can redeploy it a minute afterwards with the change. So it fits really, really well with that continuous integration, continuous development paradigm, CI/CD in the DevOps world. And also containers, just to continue here, they are really, really scalable. So you really spin up, you can do bursting, you spin up containers where you need them. If you grow in EMEA, no problem whatsoever, putting 1,000 more containers for the EMEA web app and so on. So scaling is really well. And you see that if you look at the number, it's a good thing. It fits really well with DevOps. So the adoption in the real world is also really, really high. As we speak today, there are 500,000 Dockerized apps available on the Docker Hub. The Docker Hub is one of the official repositories where Docker containers or images are available. And last year there were 24 billion Docker image downloads. So adoption is really, really high. Is all good? It looks very good, right? No, not all is good, because if we start to look at security now, we see that only around 20% of companies which use containers in production actually do some scanning, which means 80% of them just take the images and deploy them without any testing. So they do not really know what is in their container images. Sorry. And if we look what's in those containers, we see that in the official images that come from the vendors of these images or from the creators of these images, there are in average 16 vulnerabilities in one Docker image. And if you take into account that it's very easy to publish your own images, so if I take the official image for Alpine Linux, I make a couple of changes, I install a couple of packages, and I republish that. If I look at the community images, I see there's almost, well, there are more than 50 vulnerabilities per image in what's available in the registries today, and that's quite massive. We have also looked at images. We have scanned images that were used by some of our customers, and we have found that the general security score for their container images is really, really bad. So American, it would be grade F, which is the lowest grade available. So we have a very high adoption rate because it makes sense, because it integrates well with DevOps. On the other side, developers are not really known to care too much about security. So something needs to be done in order to rectify that situation. So first question is, do we need to change? Of course we need to change. Already due to the fact that containers are so short-lived compared to a traditional VM, a virtual machine which lasts in average 15 days, we are down to an average of 2 days with containers, and that is getting even shorter. So in many instances, for example, I mentioned Netflix before, the container only lives while you watch the video. So there we speak about minutes or hours maximum where a container lives. And it means that we necessarily have to change the way we think about security, because containers are not made to be remotely managed. Nobody is going to patch a container if it lives only such a short time. So we absolutely need to change. Problems are the short lifespan. I have mentioned that before. A container does not necessarily have an IP address. It's not remotely manageable. So we cannot just take a Nessus scanner and do some remote external scanning of those running containers. We need to do something else. And then remediation is not going to be done via patching. So as we will see, we need to address those things directly in the development cycle, in the build cycle, and that's what we will see in just a second. IT operations people or DevOps people have been asked that they think if they think that security slows them down, and of course, developers and operations and security doesn't go well together, and that's why we need to bring down the boundaries, especially between security and development and operations, to create a smooth process such that everything works nicely. And I quite like that picture here. So DevOps is really, really something nice. You can do great things with DevOps, and this is really the future. But then the security guys, they have to clean up all the crap that comes out if you look at it from a security perspective. So vulnerability management and reducing vulnerability in container images and so on only works if security is part of the development and build cycle. That's really the essential point here. So something needs to change. We are now sure about that. It's not really the question whether we need to change, but we need to change. So what could be the attack points? Where could we attack that problem? So first we need to understand the build process and how containers are managed. So containers are a dynamic thing. Containers are the things which are used in production. They are based on container images. Images are what is built by the developers. Images are a static thing. So they are created and they are available to be deployed as dynamic containers in production. So in another way, you could say that container images are really templates for spinning up containers in the cloud, for example. Then we have so-called container registries. The best known container registry is the Docker Hub. There are other container registries as well. These are really, you can think of it as a folder. It's where the container images are stored. And then based on these container images, the dynamic, the production containers are deployed into the cloud. Now, the tools that are used in this here are tools like Jenkins, which is a tool for building software. Travis, then on the top right, the Docker Hub, or on the bottom right, the Amazon ECS registry. And why am I showing you these logos here? I'm showing you these logos because these are the tools that developers work with. So necessarily, if we want to secure the containerized world, these are the tools we need to work with as well. Then next step, we need to, how is prioritization done? Because if you look at classical vulnerability management, how does it work? You take your Nessus scanner, you scan your environment, and you get a lot of results. And the vulnerabilities, they are critical, they are high, they are medium, they are low. But this is not how it works here, because we might not be able to scan a container, or it doesn't have an IP address, it doesn't have any exposed services maybe, so it doesn't really work. How do we prioritize if we cannot get a classical severity from a vulnerability scan? Now, to illustrate this, I take the example of a major video publisher on the internet that uses a single container image to check every video which is uploaded to them for malware, for security issues. And you can think that this container image which does the security checks on the uploaded videos is really important. So from this, we can deduce that we need to focus on what the container actually does to prioritize vulnerabilities management rather than on scan results. So the important thing here is look at the function of the container, and this will give you very, very strong indications of the prioritization of vulnerability management. Then before getting to the solution, here we have a recipe. I think it's might be for pizza dough. There's flour, there's salt. So this is what I think, if I look at a recipe, this corresponds to a container image. So the container image, so to say, on which the production containers are built, it's like the recipe on how to build the container. And if we know the recipe, we want to make sure that the recipe is good before we build thousands or 10,000s of containers. So before we make a lot of pizzas in this case, we want to be sure that this is a really, really good recipe. And that's what we are going to do with vulnerability management. So we take the container image, we take the recipe by which all the containers are built, and we are going to that step by step to see how this container image is built. And if we have done that test and we know that the recipe is good, then we can deploy that container into production at 1,000 times, at 10,000 times. We do not really care. So we basically shift from scanning the dynamic assets for vulnerabilities to the left side to the entity which builds the container. So we have a very, very good look at the container images and before we deploy them into production. Now, if we speak about classical vulnerability management, there is also normally a report. So how are we dealing with that? Developers don't like PDF reports, and nobody ever has asked for a 300-page security report on containers, even more so because they are so short-lived. What do you want to do with a PDF report detailing all the vulnerabilities for something that lives only for an hour? That doesn't go together very well. So what the developer wants to see is something like that. When he uses his normal build tool like Jenkins and he builds his software, he will get some messages, some error messages maybe, that there was a compilation failure, there's still some bugs. And what we want to have is that we want also to have the security information in here. So if there are problems with security, with malware, with vulnerabilities, this should be written directly in the report from the build process. So the developer will do the same thing as to whether he's fixing a bug or he needs to remediate some security issue. There's absolutely no point in distributing reports as is done with classical vulnerability management. If we want this to work, it needs to be integrated into the build process directly. Remediation, and I've mentioned a couple of times already that patching is something which is not really possible. So how do we remediate if we see that there are vulnerabilities in our container images? And I haven't recognized this. Apparently this robot type is called a Dalek, and it's from Doctor Who television series. And these Daleks, they are really made to kill and to exterminate. So remediation in the container world is really about exterminating everything which is bad on the container image. So the goal really is that the build is successful. If the developer starts the build process here in as shown in Jenkins, we should be sure that, and that's why I go back to this slide here, we should be sure that all potential vulnerability flaws, all potential vulnerabilities have been exterminated in order to successfully finish the build process of the software. Which means in turn that verifying that the build process includes security, the security part really becomes prevention. If we look at that from an architectural point of view, it means that the developer uses his tools for source control, Git being very strong in that domain, of course. They use their own build tools. I've mentioned Jenkins, Travis, there are others as well. And then the central point becomes the registry, or becomes one of the registries. And we have created a container image registry where we do very sophisticated vulnerability management and security checks. So whatever is uploaded to our container registry is checked for vulnerabilities, for malware. It can be checked against compliance, whether compliance against industry standards or compliance against your own baseline that you have, and this can be monitored continuously from that. Then that registry is really the central point, because we build container images and publish them into that registry. And if we look at the operations side, operations, the orchestration tools like Kubernetes, like Swarm, like Docker Swarm, they access this registry to pull container images to deploy the production containers. So the registry is really one of the central points, and it's the point where we have decided to implement security. So if we look at sample use cases, how could it look like? So developer has his source control tools like Git, and he does version control with Git. Yeah, let's build the picture right away. So in this case here, our container security or our image registry would be the central part. So the developer works with his tools, works with Jenkins, and builds his software directly into the Tenable IO container registry, where we do all the necessary checks, as I have mentioned, malware vulnerabilities, and so on. And in this scenario here, the production containers would be deployed directly from this Tenable container registry. But it does not necessarily, there are some other use cases as well. So we could also imagine a use case based on the Docker Hub, which is the most commonly used container registry. So again, the developer would have his own workflows centered around his tools and would publish the container images into Docker Hub or into a private registry. That could also be the case. And the workflow would then be that we have scripts in place which periodically pull, or which on demand pull new container images from the respective registry back into the Tenable IO registry, where we execute the necessary security checks and provide the result of the security checks back into, for example, Docker Hub here at the bottom. And production deployment would then be done direct from Docker Hub or whatever internal registry you would decide to use. So, in reality, how does this look like? That's the overview dashboard that you would have for your registry. So you could create a number of repositories depending on your projects, upload your container images, and it would really already give you a first overview of how many vulnerabilities are in your container images in total, how many vulnerabilities are in your images compared to other customers, because we take anonymized statistics and telemetry from these systems. We can really see what is the industry average. We have seen before that in average from official registries, we had like 15 vulnerabilities per container image, and from community images it was around 40. So you could easily check against that baseline, and in this case here we have 6 vulnerabilities per, or that's here. Here we have 1 vulnerability per image, which is extremely low. So you can do a comparison against the baseline, and if you bring that information together with how important a container is for your software, for your web application, you can start to do prioritization based on the data that you get here from the registry. And if you know a little bit about, I mean, these are just statistical data, and which help you see how you compare against your peers, how you evolve over time. But if you know some things about traditional vulnerability management, you are of course also interested in the specific vulnerabilities. And this is what you get if you then go into the container images and look at specific container images. So you can see all the vulnerabilities, all the CVEs. You can see what we think that the risk is for this specific container image based on the detected vulnerabilities, which also gives you more context. It gives you remediation instructions. So you can really see what needs to be done to become better, and not only to evolve over time and reduce the attack surface over time. So you get all that if you use that specific image registry and integrate it in one way or another into the build process of your software. So that is a bit short, but that's really the overview I wanted to give you. Are there any questions so far? Yes?
A couple of questions actually.
Uh-huh.
So from an observation point of view, you're talking about...
Do you rather have a mic, sir?
I should have eaten more pasta to be live.
Yeah, is this better? Yeah. So I have an observation and a couple of questions. My observation is you spoke up, or you started a topic as vulnerability management in containers. And I think a big chunk that is missing, because I mean, I understand you're positioning the Tenable product, but it's still looking at it from a traditional scan of a static set of files. A big chunk that is missing is the code that the developer has written and security scanning of that code. So there are tools obviously which are out there, but they do that. And I think from a holistic picture point of view, integrating those tools in things like Git before pre-commit, etc., whenever you want to do in the process is important. From a question point of view, I assume Tenable.io is a web-based service. So how does it integrate with products like OpenShift? And the second question is, again, from a process point of view, yeah, I do understand containers have very short life, but sort of the observation I have is still the enterprises use a container for about 3, 4, 5 days. And if you have a container out there which is vulnerable, is there anything that you have which in terms of sort of can go out, seek such vulnerable containers and help destroy them? Thank you.
Okay, so let's start with the last part. We don't have anything, so it really comes down to the slide where I showed the pizza recipe. So we want to make sure that containers are not vulnerable before we deploy them into the cloud. So that is our philosophy that we follow for the moment. And the answer really is no. At the moment, we don't have any tools which dynamically analyze deployed containers and destroy them if necessary. This is on the roadmap, however. So that's the first part. That's the static analysis of the container images, and dynamic runtime container analysis is something we speak about maybe in 6 months time frame or so. And then, of course, you are right. There's something else missing, which is analyzing the code of the developers, and that's not something we do today. However, if you look at the way DevOps works, there is a very, very high amount of reusing existing containers, modifying them, adding other third-party packages. So a lot of things are based on things which already exist. So we're quite happy that we can already cover that part. As for custom code, this is still missing. As with regard to collaboration with, you've mentioned OpenShift. So I would go around that question and say that Tenable.io is also available on premise and not only in the cloud. So I would do the integration that way. As for the cloud, we would need to, maybe you can come over and we can have a look at the strategies we could use there, but I would do that on premise. So.
Thank you. Hello, I'm starting my own DevOps company, so I've got a few questions. I see that you are able to do container security, but what about orchestration security? Are you able to scan, for example, Kubernetes configurations or Ansible scripts to check for available issues?
No, not yet. We can do some compliance scanning to see that Kubernetes is really correctly configured and so on. So we can do that against industry standards, but really look at the content of the scripts and that's something we're working on. So to be very honest, that's something quite new, and it's highly dynamic. So it's in development, and it's one of the things we are looking at. But what you have as we speak today is more like the static analysis of the container images and the registry functionality here. So maybe next year. That'd be great. Any more? Yeah, there is one.
Thank you. I'm not very well aware of the functionality in, for example, Docker Trusted Registry, but you have something like Docker security scanning. Can you compare your tool to that?
So, absolutely. So, for one thing, we are really the vulnerability management company. So we have research teams. We have a very short turnaround time on new vulnerabilities to integrate them into our solutions. We have large teams which do that. So one of the advantages is that you have really excellent quality raw data about the vulnerabilities we are looking for in the product. And then also, if we speak about products, container security is just one module of our larger vulnerability management solution. So this means that there is container security, which we have spoken about exclusively today, but there is also web application scanning, there is traditional vulnerability scanning, there is compliance scanning, all in the same thing. So our solution gives you a much broader view of what's going on, not only with regard to containers, but also with regard to the web applications that are public facing, which might use those containers. Also with regard to vulnerabilities about the hosts where Docker is running on. Also about the compliance, how well is Docker configured according to CIS standards, for example. So you have one single tool which gives you visibility about the host, about the containers, about the web application itself, all in a single user interface. So it gives you so to answer your question, it gives you a much broader view, not only for containers, but really for the whole gamut of assets. Plus, I think we are really, really strong on vulnerability data and giving you context about these vulnerabilities, on how to remediate them, on how to prioritize them, on giving additional technical and threat intelligence context on these. Okay, any more questions? Doesn't seem the case, so thank you very much. Enjoy the rest of the conference. Enjoy the capture the flag for those who do, and see you around. Thank you very much.